for Tuesday and Thursday of this week. They will be due next Thursday, so bring those in with you next Thursday. The videos for those are all out there on YouTube already. Definitely make sure you take care of those. And then exam 4 is due Wednesday night, midnight, before class on Thursday. And it covers Tuesday's lessons and today's is what it covers. And so it's straightforward what we've talked about in class. I mean, it's the examples that we've done should definitely help you with the problems on that exam. And then the final exam is on Thursday, 9 o'clock. We'll have a 2-hour time limit on that. And I'll have formulas that you might need. I'll have those on an answer document for you, or on a sheet of formulas that you might need. Make sure you've got a calculator, and I'm not doing the bubble sheet thing for the final. Just anything to write with. You don't have to have a number 2 pencil or anything for that, for the final. Just something to write with. I'm just going to do it with a, you write your letter of your answer instead of bubbling the bubbles, because there's not really a good way to do that with the distance learning in here too. So, but that'll be Thursday, 9 o'clock. We'll start the test at 9. You'll have till 11, or if you get done. And then labs going to turn in before that. So I'm hoping that I can just sit while y'all are taking tests and grade those labs and get all that stuff out of the way, so that when I grade your final, I can put your grade out there and tell you what you got, so you're done. So Thursday, make sure you're on time for the final, because if it starts at 9 and you're late, you will lose that time. It's ending at 11. That's the way it's going to go. But make sure you get exam 4 finished by Wednesday night. I know the Independence Day, 4th of July is mixed in here, so take that into account, that your Tuesday may be a little different than your normal Tuesday is. I know my Tuesday is going to be different than my normal Tuesday is, because it's 4th of July. So we got some family things and various other things going on. And then this weekend got that holidays in there this weekend too. So got a lot of things going on there. So make sure you manage your time wisely between now and Thursday, so that you're ready for that final. You've got everything done, because there's not a lot of time. There's no time after that to do anything. So make sure you got all that done, and we'll be finished with the course. Y'all got any questions for me before we get started? All right. Well, let's get going with 3.3 and 3.4 today, talking about polynomials and their zeros and their factors is what we're going to be talking about today. A lot of the same stuff that we talked about on Tuesday at the end is going to be used today. Determining if something is a factor or not is that yes, no question. That's the beginning of today. It's where we left off last week or on Tuesday. So we're mixing all that back together, and we're going to take it a little step further and factor the polynomial, find all of the zeros for a polynomial, and then actually, what if they don't tell us anything at the beginning about the polynomial? What do we know about it based on the things that we're going to learn today? So quite a bit of stuff, but packed into these two things, but it's all very much related. And once you've got the skill set, it's not incredibly difficult to do if you can just follow that process. All right, so first thing we're going to talk about is factoring a polynomial, and we're going to start where we left off on Tuesday with testing, is something a factor or is it a zero of the polynomial, and then build on that. So remember that if k is a zero of a polynomial, and k just means a number, if that's a zero of a polynomial, then x minus k is the factor that goes with it. Okay, so that's what we're building this premise off of. That's a factor and remainder theorem. And remember, if it is a factor, when you do synthetic division with that that k value, then the remainder is going to be 0. If it's anything other than 0, then it's not a factor, and that kind of stops you where with that particular number. So we're going to take that and we're going to build on it today. So let's start where we left off on Tuesday with this particular problem. We're not going to factor this one completely, but we're going to start with just reviewing the synthetic division process. So we've got this polynomial, f of x is equal to 3x to the fifth minus 2x to the fourth plus x to the third minus 8x squared plus 5x plus 1. So this really large polynomial with a degree of 5, and they want us to answer the question, is x minus 1 a factor of that polynomial? So to answer that question, we're going to use that idea that's up here in the start statement, that if k is a 0, then x minus k is a factor. So that means that x minus 1, if it's a 0, a factor, then it's equal to 0. So x would equal 1 if you solved it. So this is the number we're going to use in synthetic division. Okay, we're going to use the positive 1 up on the shelf for our synthetic division. So there's the 1 goes up there, and remember the coefficients fill in the top row of our synthetic division setup. Okay, so we got the positive 1 up here, then we got the coefficients in the top row. And the first step for synthetic division, remember, is to drop that 3, the first term, down, and then multiply and add. So 3 times 1 is 3, negative 2, negative 2 times 1, add. Did I do that right? Yeah. Why did I put a negative 5 there? That's why it's not working, right? Good morning. Negative 2 goes there. So that's positive 1. Let's go backwards. All right. Starting over. 3 times 1 is 3. Negative 2 plus 3 would be 1. 1 times 1 is 1. And then 2. 2 times 1 is 2. Negative 8 plus 2, negative 6. And there's negative 1 times 1 is negative 1. And there is our remainder, that last piece, being a 0. So is x minus 1 a factor? Then the answer to that is yes, because that remainder was 0. Okay? And what that would allow us to do then would be factor the polynomial a little bit with an x minus 1, and then the other factor that we know of right now is 3x to the fourth plus x to the third plus 2x squared minus 6x minus 1. And then nothing after that because we've had a remainder of 0. Okay, so that's the factored form so far. What we're going to do today is build on this further and start factoring that bigger polynomial that's left over. We're going to do some more with it today and build up to that. All right, so remainder's got to be 0 for it to be a factor, and the k value to be a 0 of the polynomial. So the remainder's got to be 0. Okay. All right, let's look at another example. F of x is equal to 2x to the fourth plus 3x squared minus 5x plus 7. And we want to know, is x minus 1 a factor? We're going to check the same factor and see if it works for this polynomial. Okay? So again, same idea. You're going to take whatever factor you're checking, set it equal to 0, and that's going to give you the number that goes on the shelf. Okay, so we're checking the same one, so it's the same k value we're checking. We're just putting 1 on the shelf, and then we're putting that polynomial on the top row, the coefficients. So we have 2x to the fourth and then 3x squared. So that means there's a missing piece. There's an x cubed that's not there, so we put a 0 in its place. Be careful of that. If you don't put it there, it's going to mess things up. Not going to work out for you. And then minus 5, and then 7. So we got a representative from x to the fourth, x to the third, x squared, x, and then no x's. And then you run your synthetic through there, and we're looking to see if the remainder is 0. If the remainder is 0, the answer is yes. If the remainder is anything else, then it's no. So drop the 2 down, multiply, add. Uh-oh. Remainder is 7. So what that tells us is that x minus 1 is not a factor. Okay? And then from there, you know, we would have to do something else, and we're going to talk about what to do in just a little bit when that doesn't work that way. All right. So now let's get into factoring a polynomial completely. All right. So we'll start out with this polynomial f of x is equal to 6x to the third plus 19x squared plus 2x minus 3. Okay. And they give us a bit of information here. They tell us that x plus 3 is a factor of that polynomial. Okay. So if I'm asked to factor something completely, I look at it and I try to follow the rules of factoring first, which would be, okay, I'm going to look for a GCF across everything. There's nothing that goes into all 4 of those terms. And then I say, okay, well, it's got 4 terms. The next option would be grouping. But if I group these together, the first 2, I can't pull anything out other than x squared, and that's not going to allow me to get the parentheses to match. So I can't use grouping on this because it doesn't work. So that's where I've got to have that bit of information that x plus 3 is a factor. Okay, and they're giving that to us right now. We're going to build up to where they don't give us any information about it. We've got to find it out on our own. But if they say x plus 3 is a factor, that tells me that I can take this polynomial and break it down a little bit with synthetic division. And that's what I want to do, is break this polynomial down with synthetic division. What goes on the shelf for this synthetic division? Not 3, but negative 3, because you got to solve that for x plus 3 equals 0, and it's negative 3 that goes up there. We're going to run a negative 3 through with synthetic division, and that's going to allow us to break this polynomial down. Remember, synthetic division reduces the polynomial by 1 degree. So we're starting out with a polynomial that's degree 3 because the x cubed there. When we do this synthetic division with x plus 3, they told us it's a factor. So the remainder better be 0, or they lied to us. They're not going to lie to you. Okay. So the remainder is going to be 0 if we do it correctly. That's going to break it down into an x squared problem from there. And that we know how to work with those. Okay, so drop the 6 down, multiply. And then add through there. And there's my remainder of 0, which I knew should have happened. Okay. What that means is that we've now got this polynomial to where x plus 3 is a factor, and then this left over is actually that trinomial right there. 6x squared plus 1x minus 1. And something with 3 terms, we factored that before. Okay? And if I'm going to factor something with 3 terms, I'm going to use that x method to do it. Let's have a little bit more room here. And if I use that x method, 6 times negative 1 is negative 6. We want it to add to be positive 1. So that would be 3 and negative 2 that does that. So that would allow me to go 6x squared plus 3x minus 2x minus 1. And then group those. And then that group would pull out a minus 1. And now I've got the factors 3x minus 1 and 2x plus 1 for this trinomial right here. That's the factors for that. But I also have the factor that I started with, x plus 3. There is our factored form for that polynomial. So we used the synthetic division to get the ball rolling and get the problem broken down into something that I can then factor using some of the skills that I already have acquired in factoring a trinomial. I knew how to do that. So that allows me to get there. And I got it in factored form. All right.
I'm sorry.
Go ahead.
What is the x plus 3 and 3x minus 1? Where's the x plus 3?
X plus 3 came from up here where they told us that was a factor. We verified that through the synthetic division with the negative 3. And that's the one that they tell us out at the beginning. So that came from the synthetic division. So maybe this comes from here, and then there's that one. Maybe I'll use a different color. And then this is that one. That's where those are coming. All of those are separately coming from. Okay. We're going to do several of these today. Don't think this is. We're going to do one example and go on. We're going to do several of these. You're going to get a lot of practice at this. It takes a bit to kind of catch on and say, oh, well, it's the same thing over and over. Just I got to know how many times to do whatever with that. So, all right, let's look at another one. And I think maybe it'll start. Maybe a light bulb will come on and you'll say, oh, well, that's not that bad. Here's our function. F of x is equal to x to the third power plus 4x squared minus 5. And x minus 1 is a factor. Okay. So here again, I'm giving you the information that x minus 1 is a factor of that polynomial. Okay. So they've given you one of the factors. You got to find the rest of them. All right. So if x minus 1 is a factor, that means if I set up synthetic division to break this polynomial down, what goes on the shelf? 1. Because when you set that equal to 0, you get x equals 1. And that's what goes on the shelf. Okay. And then fill in the top row, 1, 4, 0, negative 5. Again, got to remember to put in the representative from plain x on this one because it's not in the problem. Got to have a rep from the highest power on down. As we put a 0 in that place. And then run the synthetic division with this positive 1. Okay. So 1. Okay. So that means we have this polynomial left. And I want to try to factor that. It's got 3 terms, so I'm going to try the x method. Is there anything that multiplies to be 5 and adds to be 5? No. If I did 5 and 1, that's the only options for multiplying to be 5. That adds to be 6. So that doesn't factor any further. And that's okay that it doesn't. If it did, I need to do it. But if it doesn't, it's okay. That means the factored form for this polynomial is going to be the x minus 1 and then x squared plus 5x plus 5. And that's your factored form for this one. That's what that's for. Because that quadratic, that x squared plus 5x plus 5, doesn't factor, I have to stop and leave it that way. Okay. Example E. We're going to factor given a 0. Okay. So problem's going to look slightly different, not much. Still the polynomial. We got 2x cubed minus 3x squared minus 5x plus 6. And then k equals 1 is a 0. So they tell us a 0 instead of the factor. Okay. The work is exactly the same, guys. It's no different. The only difference is what goes on the shelf. Yeah, that 1 that's there, you don't change the sign when they tell you it's a 0. If they tell you it's a factor, you got to remember to change the sign. If they tell you it's a 0, then you don't. I'm setting up my synthetic. Got the 2, -3, -5, and 6. And I'm going to go through there and I'm going to run the 1 through. 2 times 1 is 2. I got a remainder of 0. I should have. They told me 1 was a 0 of this polynomial. So I should have got that the remainder was 0. What that allows me to do then is take 2x squared minus 1x minus 6 and factor it using the x method, or at least try to factor it. And 2 times -6 would be -12, had to be -1. That's -4 and 3. So I'll write 2x squared minus 4x plus 3x minus 6 and group that. The first two have 2x in common. The second two have 3 in common. So the factors for that quadratic, that 2x squared minus 1x minus 6, the factors for it are x minus 2 and 2x plus 3. What's the factor that goes with the 0 they gave me? There's a third factor here that they told me about at the beginning, but they didn't say factor, they said 0. X minus 1. Good job. That x minus 1 came from where, it said k equals 1. Remember that statement at the very beginning of the note said that if k is a 0, then x minus k is a factor. So that's where the x minus 1 came from. Those two, go together. Okay. And that's the factored form for this polynomial. If you can get the factored form, the next thing that we'll do is easy. But getting the factored form, if you can't do that, it makes it tough. Okay. But synthetic division, get it down to a quadratic or x squared problem. And then use your skills from that to finish it off. Okay. So we're going to do synthetic division, get it down to a quadratic, and go from there as far as that goes. All right. So this is what we want to do. We want to take this idea and extend it into finding the zeros for a polynomial. Okay. So we're going to build on the factoring idea to find the zeros of the polynomial. And the great thing about it is if we've already got it factored, to find the zeros, all you got to do is set each factor equal to 0 and solve them. So if you get it factored, finding the zeros is the easy part. The factoring is the hard part. I don't discount that. The factoring is the hard part. The zeros is the easy part, because if you can get it factored, all you got to do is, these are all 1 or 2 step problems. Just set them equal to 0 and solve. Okay, so let's look at some problems and see if we can build the idea of getting all the zeros for that. All right, so going to try a couple of different attacks here for this, because there's different options depending on what's happening. So let's try this one. Let's see if we had. Say we had f of x is equal to x cubed minus x squared minus 4x minus 6, and 3 is a 0. Three is a 0 of that polynomial. We want to find, the instructions would be find all other zeros of the polynomial. Okay? So if they tell me one of the zeros, I'm going to use that 0 in synthetic division. I'm going to put 3 on the shelf and then run that through with synthetic division. They tell me a 0, I'm using it. Okay. All right. So that tells me x equals 3 is a 0. So maybe over here it can be helpful to just say, okay, here are my zeros. X equals 3. That's the one they told me about. And then I'm going to find the rest of them. Well, I did that synthetic division from an x cubed function. I broke it down one time into an x squared function. So I have x squared plus 2x plus 2. And I want to try to factor that if I can. I want to try it. So I want it to multiply to be 2 and add to be 2. Uh-oh. Is there anything that does that? The only things that multiply to be 2 are 2 and 1, or negative 2 and negative 1. And neither of those are going to add to be 2. So what does that mean about the factoring of that quadratic? It means it won't factor. But that doesn't mean I can't solve it. Remember back when we did quadratics a couple of weeks ago, we had the quadratic formula that we could use to get the zeros of a quadratic if it wouldn't factor. It even works if it will factor. Now, that's a great thing. So once I get it to a quadratic, I can use that quadratic formula. Remember, negative b plus or minus square root of b squared minus 4ac divided by 2a. That was the quadratic formula. I can use that for this problem so that I can get the answers, even though it won't factor. Okay, we'll look at one in a minute that does factor all the way and see what we can do with that. But the quadratic formula is awesome because it always works, though. So I'd have negative 2 plus or minus, and I'd have 2 squared plus 4 times 1 times 2. All of that divided by 2 times 1. And I just need to work that out. Negative 2 plus or minus. Well, 2 squared is 4. So this right here would be 4 plus 8, which is 12. So we got the square root of 12 there over 2. Well, I'm going to break 12 down. 4 and 3. Got a pair of 2's. So I have negative 2 plus or minus 2 square root of 3 over 2. Now, I want to simplify that because this, and this are all divisible by what number? 2. So I'm going to divide them all by 2. So that's going to be negative 1 plus or minus radical 3, all of that over 1. So I'm just going to write it like that. So I have zeros, x equals negative 1 plus radical 3, and x equals negative 1 minus radical 3. Those go along with the 0 that they told me at the beginning. I'm going to get the decimal approximation for those as well. And then x equals negative 1 minus the square root of 3. I want to get the decimal equivalent for those as well. So negative 1 plus the square root of 3, 0.73, and then negative 1 minus the square root of 3, negative 2.73. The blue one is the one they told me about at the beginning in their list of zeros there. The blue one they told me about. The 2 red ones are the ones I found using quadratic formula. Okay, so it takes, that synthetic division is going to help us break the polynomial down, and we want to break the polynomial down to where we get an x squared problem, because then we get factoring and we get quadratic formula as options on that when we break that polynomial down. All right, so let's look at this next one. Sample G. Let's say we had this function. F of x equals 6x cubed plus 25x squared plus 3x minus 4. And they're telling me that negative 4 is a 0. And we want to find all the rest of them. Okay? That means there's 2 that we got to find. The degree of the problem tells you how many answers you should have. This one has a degree of 3 because it's the highest exponent's 3. It's x cubed. So 3 on the exponent, the highest exponent's 3. That means that there's 3 answers to this problem when you're trying to find the zeros. They gave us one of them. We just got to find the other 2. Okay? And the way you want to start out by just taking that 0 that they gave you and using it in synthetic division to get that polynomial to break down a little bit. Okay? So I'm going to drop the 6 down, multiply. And there's that 0 in the remainder. That's what should happen. Okay? So over here, we got our list of zeros. X equals negative 4. That's the one they told me about, and that's the one I used first. Okay? The next thing I want to do is take this quadratic that I've got here and try to solve it or try to factor it. Okay? I think this one will factor because I need something that multiplies to be negative 6 and adds to be positive 1. What does that? Yeah, -2 and +3 multiplies to be -6 and adds to be +1. So that allows me to go, okay, well, that's 6x squared minus 2x plus 3x minus 1. And group that. 2x, and that'd be 3x minus 1. Nothing in common between those two, so that's automatically a 1. So the factors are 2x plus 1 and 3x minus 1. If I'm trying to find the zeros, I set those equal to 0. That's what it means to be a 0. So I set 2x plus 1 equal to 0 and 3x minus 1 equal to 0 and solved them. Subtract 1, divide by 2. X is equal to -1/2. And then this one over here, going to add 1. Divide by 3. X is equal to 1/3. So our zeros we get are the x equals -4 that they told us about. And then we get -1/2 and +1/3. So x equals -1/2, +1/3. There's my zeros for that polynomial. So the process we're going through is synthetic division with the 0 we know about, get it down to an x squared problem, then either use factoring or quadratic formula to get the other zeros. Let's look at another example. Let's say we had f of x is equal to x cubed plus 4x squared minus 5. X equals 1 is a 0. X equals 1 is a 0. So I'm going to use that in my synthetic division. I'm going to use a 1 on the shelf. And then polynomial 1, 4, 0, -5. Run that through with synthetic. Drop the 1, multiply, add. There's that remainder of 0. If that doesn't happen, you did something wrong. If they tell you something's a 0 and you don't get a 0 remainder, something went wrong with your work. That's always a checking spot. Yep. Now, from there, you're going to take this, that tells you x equals 1. We know that that's a 0. We got to find the other 2 that go with this problem. We know there should be 3 because it's x cubed. So x squared plus 5x plus 5. I always try factoring first. I know that this one doesn't factor, though, because there's nothing that multiplies to be 5 and adds to be 5. Okay. If it was a 6x in the middle, then hey, then we're in business. But it's a 5x in the middle, so it doesn't work. So this doesn't factor. So my only option for solving it, or the only logical option for solving it, not the only option for solving it, is to use quadratic formula. So I'm going to set it up. X equals -b plus or minus the square root b squared minus 4 times a times c divided by 2 times a. I'm going to work that out. So I'm going to work that discriminant underneath the square root there. Be 25 minus 20 is 5. So I end up with negative 5 plus or minus the square root of 5 over 2. Well, that doesn't, the square root of 5 doesn't simplify any. So I'm done with that part. I get two answers. I get x equals negative 5 plus the square root of 5 over 2, and x equals negative 5 minus the square root of 5 over 2. I'm going to go ahead and get the decimal equivalent for those, or a decimal approximation for that, because I can, and it's helpful if I have to know something about a graph later on. So negative 5 plus the square root of 5 divided by 2. 1.38, excuse me, negative 1.38. Then do the minus. Negative 5 minus the square root of 5 divided by 2. Negative 3.62. What that means, and what we're going to build on in just a little bit, is that if we graphed that polynomial, x to the third minus, or not minus, but plus 4x squared minus 5. I'm going to have to fix my window here. Zoom 6. Oops. Zoom 6. I'm graphing that with my graphing calculator. Look at where it's crossing the x-axis. It's crossing the x-axis right there at positive 1. That was a 0. Right here is negative 1 and some change. This spot right here. Let me copy that to my notes so I can write on it and you can actually see what I'm doing here. So there's the graph that I did on my calculator. Right here, that's your x equals 1. That's where it's crossing the x-axis. That spot right there is your x equals negative 5 plus the square root of 5 over 2. This other piece over here, that's between negative 3 and negative 4. That's the negative 3.62 or something like that? Yeah, negative 3.62. That's your x equals negative 5 minus the square root of 5 over 2. That's what all those points are. That's what we're finding. When we find zeros, that's what we're finding. It's where it's crossing the x-axis. Now, is there any way you could have guessed these negative 5 plus and minus the square root of 5 over 2? No. You could get close. You could get the decimals and get close. You could, with your graphing calculator, you could hit, trace and go over it, get close to that. Oops, too far. See how close I can get hitting trace there. There's negative 1.36. That's as close as I could get. That's pretty close, but it's not quite right. Okay, so you can't guess them. You can get close to them though. We're using the graph. We can find them using the algebra, and that's the important. That's what we're trying to get at here. This is what we're finding. This is it doesn't necessarily always equate to we were able to guess at them on the graph there. So that's what we're finding. Let's look at another example here and see what we can do with it. Example I. Let's say we had f of x is equal to 4x to the third 6x plus 6x squared minus 2x minus 1. X equals 1/2 is a 0. All right, so we're going to run 1/2 through using synthetic division. It's a fraction, but that's okay. It's not a big deal. Just a number. And the good thing is I know that I should have 0 as the remainder here. So I'm going to run 4 times 1/2 is 2, is 8. Half of 8 is 4. Half of 2 is 1. And there's my remainder 0. Worked out pretty nice. It wasn't that bad. X equals 1/2 is a 0. We knew that already. It really didn't surprise us any. All right. Now, that gives me this quadratic equation to solve. I got 4x squared plus 8x plus 2 equal to 0. I've got to solve that. So my options are factor it or use quadratic formula. So I'm going to start with factoring because that's the thing that can make things go faster. Quadratic formula takes a little more time. So I always try to factor first. What do I know about 4, 8, and 2? Yeah, they're all even. They're all divisible by 2. So I'm just going to divide them all by 2 at the beginning because I can. That will make my life easier. Technically, I'm dividing the 0 over there by 2 as well because that, that's what allows that to happen is that you can. All that does is makes the numbers smaller, which is always easier. When numbers are smaller, things are easier. Okay. So I could try factoring. It's pretty obvious that this one is not going to because we need something that multiplies to be 2 and adds to be 4. 2 plus 1 is 3, not 4. So it doesn't work. So that means I'm going to have to do quadratic formula. The great thing about dividing by 2 at the beginning, though, is that my quadratic formula is easier because it's smaller numbers. Quadratic formula gets much tougher when it's really big numbers. We want smaller numbers. So smaller numbers are good. So let's do that. X equals negative b plus or minus the square root b squared minus 4 times a times c divided by 2a. And work it out. So this is going to be 16 minus 8, which is 8. 8 breaks down to 2 radical 2. And then it's a 4 on the bottom. So I just did the part underneath the square root. I just did that over on the side. I'm writing fewer lines here. Now, I look at that and I say, okay, 4, 2, and 4, they're all divisible by 2. So I'm going to divide those by 2. I've got my answers. That's the zeros. X equals negative 2 plus the square root of 2, all divided by 2. And x equals negative 2 minus the square root of 2, all divided by 2. I'm going to get the decimal equivalents for that. So that when I look at the graph, I can see, hey, that is where they're crossing. The numbers look weird because they're in exact form, but when we put them in decimal form, they don't look quite as weird. So we got negative 2 plus the square root of 2 divided by 2. Negative 0.29. Do the minus. Negative 2 minus the square root of 2 divided by 2. Negative 1.71. So we get 3 zeros. If I were to look at the graph of this polynomial, that's what I want to do, because I want to start relating that to that graph, because that's what you're gonna be doing here. 4x raised to the third plus 6x squared minus 2x minus 1. Hit graph. I should see this thing crossing the x-axis at those places. Here's one thing I can use with my calculator. This is a skill with the graphing calculator. If you hit trace and then type in the number that you want to try, I'm going to use 1/2. That's the one they told me about. And hit enter. Notice what it gave me here. Look down at the bottom. It's got an ordered pair. It's got x equals 0.5. That's 1/2. And then y equals 0. That's the right thing. Now I'm going to try those decimals. It may not give me y equals 0, but it should give me something really close to 0 there. So what were those decimals? Negative 0.29. So I'm going to type in trace negative 0.29. This number over here, the y right there, it's not 0, but it's real close to 0. You know, a penny and some change away from 0. So that's real close to 0. Remember, that's a rounded value. If I had typed in the actual exact value, it should give me exactly 0 there. And if I type in the other 0, the negative 1.71, trace negative 1.71, and hit enter. Again, that's not, that y value over here is not far away from 0. It's pretty close to 0. And we're rounded that decimal there, but we can see that that's where it's crossing the x-axis. What that does is it says, okay, you did it right. You got those numbers right. That's the right thing to do. Okay. Relating it to the graph is the next step in what we want to do. We want to be able to take this problem and build from nothing, you know, as far as that goes. Like, we're going to get a polynomial and we're going to have to find all the zeros from it, but they're not going to tell me one of them. The next example is that way, and I'm going to show you how to do that using the graph and using some other things, the rational zeros theorem that we're going to talk about next. Okay, so this is taking this stuff, and it's the same process. The difference is they're taking this statement here that something is a 0 away from you. They're saying, okay, taking the training wheels off the bike. You got to do it on your own now. Okay, so that's what I'm going to do. I'm going to teach you to not fall down, hopefully. Here is the key. Theorem. The rational zeros theorem. If P over Q, remember a rational number, we talked about this maybe the first day of class. Rational number is just a number. It can be written as a fraction. Okay, so all the rational numbers, remember, that includes integers, whole numbers, 0. That's part of the rational numbers. It includes fractions as well. But the rational zeros theorem, what it says is if P over Q is a 0 of a polynomial, then P is a factor of the constant term and Q is a factor of the leading coefficient. A lot of words there. Constant term just means that's the plain number that's hanging out on the end. The leading coefficient, that's the number in front of the highest power on x. Okay, so we're going to build a set of rational zeros based on those factors. And the factors means like if it's the number 4, the factors of 4 are 1, 2, and 4. That's what the factors of 4 are. The factors of the number 6 are 1, 2, 3, and 6. Means a number that will divide into it even. That's what it means to be a factor of that number. Okay, so what we're going to do is we're going to take a polynomial and we're going to be able to break down the possible rational zeros from all the numbers in the world into a small list of it can vary depending on what the numbers are, that it's limited to what it could be. Okay, so that's what we're going to build off of. So let's take an example. I think it's the best way to learn this is just do some examples. J. Okay, so here's our function. F of x is equal to 6x to the fourth plus 7x cubed minus 12x squared minus 3x plus 2. Really big polynomial. And we don't know much about it, but they want us to find all the zeros. That's what they want us to do for this problem. Find all the zeros. So this is what I need to do. The first thing I need to do is make my P over Q list, my rational zeros. P for this problem is 2. Factors of 2. On the bottom, we're going to put the factors of 6. Okay. The way the integer coefficient polynomials work is that to be a zero of it, you have to be a factor of 2 over a factor of 6 if you're a rational zero for that. That's what the rational zeros theorem does. If all of the coefficients of a polynomial are integers, that always works. Okay. What we're going to do, we're going to get a list. Not all of them will work, but only some of them will. We're going to find the ones that do. Okay. So we want to get this list. I can guarantee you that there will be a question on the final exam that will ask you to just make this list. To not even do anything with them, just make the list. I promise you, that's been on every final exam for Math 100, Math 140, and Math 110 that I've ever given. Making that list is. So you got to be able to make this list. That list is also going to tell you what numbers you need to even try. Okay. Now, the factors of 2. What are the factors of 2? 1 and 2. Short list up there. But it's actually plus or minus. Because positive 1 and negative 1 both go into 2. Positive 2 and negative 2 both go into it. On the bottom, what are the factors of 6? 1, 2, 3, and 6. But it's also plus or minus on those. Okay? Now, that's not the list. That's the factors. We need to build the list based on those factors. So here's how you build that list. You take each factor that's on the top. So I'm going to take the number 1. I'm going to divide it by each one of those factors on the bottom. 1 divided by 1 is 1. 1 divided by 2, 1/2. 1 divided by 3, 1/3. 1 divided by 6, 1/6. Then I'm going to do the same thing with the 2. 2 divided by 1 is 2. 2 divided by 2 is 1. I've already got that written down. I don't have to write it again. 2 divided by 3, that's 2/3. 2 divided by 6, that's 1/3. So I've already got 1/3 written down. That's my list of possible rational zeros. So I've taken a polynomial and I've reduced the probability of finding the zeros, if they're rational zeros, from every number in the world. I've reduced it down to 1, 2, 3, 4, 5, 6, 12 numbers. Now, when I was in high school and we learned how to do this, we didn't have the nice graphing calculators that you guys have. So we had to actually make a guess and try a number. And then if it didn't work, guess again and try a number. And if it didn't work, guess again until you found one that works. You guys have the graphing calculators. That's going to help you where you don't have to guess. You can know which numbers to use, okay? So we've got an x to the fourth power problem. So we need to do synthetic division 2 times to break this polynomial down to a squared problem so that we can work it with quadratic formula or factoring, whichever way, okay? So what I'm going to do is, this is where, I was trying to relate it to the graph earlier. I want to graph that polynomial. Once I've made this list, the next thing to do is graph f of x. Graph it. And we're going to find a 0 from the graph. All right. So, graphing calculator, go to y equals. I'm going to clear out that stuff, and I'm going to type in 6x raised to the fourth plus 7x to the third minus 12x squared minus 3x plus 2. Okay. Just type in that polynomial and hit graph. I want to find a good number that where it crosses the x-axis, because that's what zeros are, or where they cross the x-axis. So I'm looking at this graph, and I look over here. That looks like +1 maybe right there. I'm going to try it. I'm going to hit trace, +1. Oops. +1, enter. Hey, what do you know? It gave me y equals 0. That means 1 works. What other number would be good to try? That it looks like it crosses at a really nice number. It's like -2 maybe. So if I hit trace, -2, yeah, it gives me y equals 0. Look at your list of possible rational zeros. 1 and 2 are in there. 1 and -2 are in there. That's what I mean. Okay? They're in that list, but we found them using that graph. You've got to be able to make the list. I promise you there's a question on the exam 4, and there's a question on the final exam next Thursday that will say, make that list. And that's all you have to do for it. Easy answering question, very easy to get it right. But doing the work with it, you use that graph to tell you where to go. So that means I'm going to use +1 and -2 in synthetic division. It doesn't matter which one I use first. Just pick one. I'm going to pick +1 first. That way, I'm pretty sure I can multiply everything by 1 and get it right on the first step. So I want to use that first. Okay? So I'm going to use +1 in synthetic division for 6, 7, -12, -3, 2. What should the remainder be for this one? It should be 0, because remember the y value when I tried that with trace was 0. The remainder should be 0 here. So I'm going to run this 1 through there. So drop the 6 down. What do you know? It is. So over here, I'm going to write my list of zeros. I know that x equals 1. And here's the great thing. I've taken that polynomial and I've started with an x to the fourth power problem. By doing synthetic division once, this red line right here is now an x to the third power problem. And if I use the next number that I know of to do synthetic division with it, which was -2. Remember, we tried that on our graph and it worked. I'm going to run -2 through this polynomial, the 6, 13, 1, -2. Okay? Drop this.
Question.
Yes, ma'am.
I'm confused at why you know that you're doing this twice.
Because I need to get it down to x squared.
Why?
Because when I get it down to x squared, I can use quadratic formula, or I can use that x method to factor. When it's x to the 4th power or x to the 3rd power, I don't have as many, I don't have the tools to be able, this is the tool you get it to get it down.
So every time it needs to be done to x squared.
Yes, exactly. That is exactly right. You want to get it down to x squared every time. So if it starts out with, what you can do is you can take the degree of the problem and subtract 2 from it, and that'll tell you how many times you need to do synthetic division. So if the degree of the problem is 4, 4 minus 2 is 2. That means I need to do synthetic division twice. So if the biggest exponent in the problem is 5, 5 minus 2 is 3. So I would need to do synthetic division 3 times there. So whatever the highest exponent in the problem is, if you'll subtract 2 from it, that tells you how many times to do synthetic division. And then you can do quadratic formula or X method factoring to get the other zeros. So here we're going to run, we did synthetic division the first time with the 1. Let's do it the second time with the -2. Right? So, and we got that -2 and that 1 from the graph. Remember that. That's the key. All right. 6 times -2 is -12. That's a 1. And then it'd be -2, -1. There's 2. And what do you know? The remainder there is 0. Should be no surprise. Because we knew that it crossed the x-axis at -2. Now I have a quadratic. And if you remember doing quadratics, I've got 6x squared plus 1x minus 1. I'm setting that equal to 0 so that I can solve it and get the other 2 zeros. This one should have 4 zeros because it's x to the 4th power at the beginning. X method of factoring, -6 add to be +1, 3 and -2. 6x squared is 3x minus 2x minus 1. Group. -1. So the factors are 3x minus 1 and 2x plus 1. Set each of those factors equal to 0. And solve them. 2 steps. X equals 1/3. And -1/2. So we get those zeros, 1/3 and -1/2. 4 zeros, because I had a 4th power in the original problem was the biggest power. 4 zeros. So the P over Q list gives you a list of numbers that you could try. And then you use the graph to help you get there. All right. Let's find all the zeros for this polynomial. So it's x to the 3rd power plus 5x squared plus 2x minus 8. How many times do I need to do synthetic division on this problem? once, right? 3 minus 2 is 1. So I'd only need to do synthetic once. I want to make my P over Q list. So I need the factors of 8 over the factors of 1. Well, that's the easiest ones to do, because what are the factors of 8? 1, 2, 4, and 8. The factors of 1 is just 1. So my list is plus or minus 1, 2, 4, and 8. So I only have 8 numbers that could possibly be rational zeros for this polynomial. All right. So what's the next thing that I should do? After I've made my P over Q list, what do I do next? Before I can do synthetic division, though, I got to know what number to put on the shelf. How do I find the number to put on the shelf? Graph it. See where it crosses the x-axis. I'm going to clear out that other one, and I'm just going to type in x to the third plus 5x squared plus 2x minus 8. I see 3 pretty good numbers there. So I've got the graph. There's my graph from my calculator, and I see that it crosses at positive 1. So I'm going to use that to do my synthetic with first. You could use any of these others, though. I mean, it also crosses, there's positive 1, there's negative 3, negative 4, and then there's negative 2. Those should be all 3 zeros. We want to verify that using the process of synthetic division and factoring to make sure that's true. Okay? So I'm going to use positive 1 because I have a less chance of messing up with signs using the positive 1. So that's why I'm going to use a 1. And there's the remainder of 0. So my zeros, x equals 1 is one of them. That got me down to a quadratic. X squared plus 6x plus 8 equals 0. From there, I can either do quadratic formula or factoring, whichever one I want to do or one that works. Can't always factor, but if you can, it's usually faster. You can always do quadratic formula, though. So I'm going to factor this one because it will. Something that multiplies to be 8 and adds to be 6. That's 4 and 2. The reason it's faster to do factoring here is because I can take that shortcut because there's nothing in front of x squared, and it's x plus 4 and x plus 2. Set those equal to 0. And solve them. Negative 4, negative 2. And there's all 3 of my zeros for that polynomial. All right. So I wouldn't use the zoom really at all. It wouldn't help you. I don't think the trace button is going to be more useful to do that. Like to get it to the regular window, just hit zoom 6. It'll get you to the regular window, and then you can zoom in on a particular point if you really want to. I don't know that it's very helpful by hitting zoom and then number 2 for the zoom in, and then move it to wherever you want to zoom into. So like if you wanted to zoom into x to the maybe this x equals 1 spot right there, you can move your cursor around to that spot. And I've hit the button a few too many times. And hit enter, and it'll zoom into that spot. Like I said, I don't think that's I wouldn't consider that as useful as the trace option, because the P over Q list is where you should get your numbers that you're even trying for the trace option. There should be the problems that you're going to be presented with. You're either going to be told what a 0 is, or there's going to be a rational 0 from your list that's going to work. So I always just use the trace option and use one of the numbers from my list, with the educated guess. Okay, well, that looks like +1, so I'm going to hit trace +1. That looks like -2, so I'm going to hit trace -2. And check to verify that y value is 0. If it's not, then it's not that number. You need to check another one out of that. All right, let's look at this one. I don't know what letter am I on. L. Say we had f of x is equal to x cubed plus 3x squared plus 3x plus 1. All right. And we want to go through the process of our P over Q list. Should be really short on this one. And then find all the zeros for that polynomial. Okay. So see if you can get that started on this one. So this one's nice because the leading coefficient's 1 and the constant term's 1. So it's just 1. Okay, so it's plus or minus 1. So it's either going to be +1 or -1 that's going to work for this particular polynomial if it's got a rational 0, and it does. So what's the next step? Graph it. That way we know what to put on the shelf to do our synthetic division with. And we're going to have to do synthetic division how many times? 1 time, because it's x cubed. 3 minus 2 is 1. Okay. So if I graph this polynomial, x to the third plus 3x squared plus 3x plus 1. Looks like the only place it's crossing there is -1. I'm going to hit trace -1 to verify that that's correct. So I know that it has the rational 0 of -1, so I'm going to use that with synthetic division. Based on that graph, that's how I know that. And I know that it had to be out of that P over Q list. And then just work from there. 1 is -1, that'd be 2. -2, that'd be 1, and that'd be -1, 0. So that gives me the 0, x equals -1. And then I've got this quadratic x squared plus 2x plus 1 there. This one will factor. I'm going to work it with quadratic formula just to get the practice with that, but it will factor 1, 1, and 1. It factors as x plus 1 and x plus 1. And I'm going to work it with quadratic formula as well. And you'll see you got the same amount of the same answers. X equals -2 plus or minus 2 squared minus 4 times 1 over 2 times 1. So that ends up being -2 plus or minus the square root of 0 over 2, which is just -1. And these both, they're the same answer. So I get -1 3 times. It has one answer, 1, 0, but it happens 3 times. What that's called is it's called a repeated 0. And another way to write that, instead of writing x equals 1, x equals 1, x equals -1 all 3 times, you would say x equals -1 with a multiplicity of 3, because it happened 3 times. If it happens twice, it's multiplicity of 2, and so on. So that's another way to write that. And you can abbreviate multiplicity MULT if you wanted to, that sort of thing. And so multiplicity. And the multiplicity of that 0, if it's odd, it's hard to recognize because it's going to look just like a regular 0. It's going to cross the x-axis. What happens, let's look at the next example, and I'll kind of show you the difference here in this one having a multiplicity of 3, and the next example has something different happening. So let's say we had f of x is equal to x cubed minus 2x squared minus 4x plus 8 as a polynomial. Okay? See if you can get it started and get going with that particular. Should have a fairly short P over Q list because we're just looking at the factors of 8. And the factors of 1 technically is on the bottom. It's always nice when it's a leading coefficient of 1 because it makes your list short and it doesn't have any fractions in it. If that leading coefficient's got a number in front, it's like a 2 or a 6 or a 72, then you got a lot of fractions to deal with. So it's nice when it's a 1 in front. Next thing to do is what? Graph that thing. Figure out what to put on the shelf. X to the third minus 2x squared minus 4x plus So this is a little weird looking on the graph part. Pop this over to. Notice you got two places that it's touching the x-axis. You got one place right here that, what number does that look like? Right there on the left side. It looks like -2. And then over here, it doesn't go through the x-axis there, but that spot right there at +2, it bounces off the x-axis. So I'm not sure what's going on there, but I know what's going on at the -2. So I'm going to use -2 in my synthetic division first. And then we're going to see what happens next. Okay. And I could verify that with my graphing calculator. Hit trace -2. And there I've got, okay, it's y equals 0. And let's use that with synthetic divisions. 1. And there's that 0 remainder. It's not a surprise. And then I've got a quadratic left over. Multiply to be 4 and add to be -4. Yeah, -2 and -2 does that. So that lets me go x minus 2, x minus 2. So that's x equals 2 with a multiplicity of 2. And this is how I usually write that. X equals 2 with a multiplicity of 2. That means it happened twice. What I want you to notice is what the graph looked like. The graph, what's happening at 2, at +2, it's not going through the x-axis. It's bouncing off of it. So anytime we have what's considered a repeated 0 and its multiplicity is even, then it bounces off the x-axis. That's what happens. If it's an odd multiplicity, then it goes through the x-axis. Like the example L, we had -1 happening 3 times. That's an odd multiplicity. It goes through the x-axis. Technically, -2 has an odd multiplicity. It's a multiplicity of 1. It only happens once, but it goes through the x-axis in the graph. If it's an even multiplicity, it's going to bounce off the x-axis. What that helps you be able to do on the much larger polynomials, if you get one that's like an x to the 5th power, and you see on the graph that it bounces off the x-axis, that means you can use that number in synthetic division more than once. Like I could have used +2 in synthetic division here and got it to work. It works. And then I could have used it again if I needed to. So that's the beauty of that. Bouncing off the x-axis means it's got an even multiplicity, and that's the ones that are easier to recognize. The odd multiplicities, hard to see those happening. The ones that have a multiplicity of 3, because it looks so much like one that's just got a regular 0 because it goes through the x-axis. The even multiplicities, they bounce off the x-axis. So that just means it's going to have a multiplicity higher than 1. It's either going to be a 2 or a 4 or something like that with the multiplicities. That's going to be handy when we talk about some things from section 3.4 in just a minute. We're kind of melting 3.3 and 3.4 together here anyway, but so we're just kind of building that. All right, let's look at one more example of this kind of stuff, and then we're going to move on. Because I know you're maybe a little overwhelmed here. All right, here's our function. F of x is equal to x to the 3rd power minus 3x squared plus 4x minus 12. going to find all the zeros for this polynomial. A little bit longer list on this one. Even though it's got a leading coefficient of 1, it's still a little longer list. We're just going through all of the steps. Same steps that we did every one of these. This one's graph is a little weird. Because how many times does it cross the x-axis? 1. But the degree of the polynomial was what? It was 3, right? So we would think it would cross the x-axis 3 times, but it doesn't. It only crosses it once. That means that we don't have all real zeros here. We have some imaginary or complex zeros out of this. We have one real one, though. What is that real one that we can tell there? It looks like positive 3. The good thing is I can use that positive 3 in synthetic division, and it'll break down my polynomial to get it to a quadratic, which is what I need to be able to solve. So I'm going to use positive 3 on the shelf there. 1, 3, 0, 4, and then there's the 12. And there's the 0 in the remainder. So I get zeros. I get x equals 3 is one of them. But then I have x squared plus 4 equals 0. Well, that's a strange looking quadratic because it doesn't have the b value in it. How can I solve that? Say it again, Madison. Perfect. Yes, absolutely. That's the easiest way to solve that one. Perfect. You could do quadratic formula with a 0 in the place of b, but you're going to end up doing the same thing. It's just taking the square root of -4. So you get x squared is equal to -4, and then take the square root of both sides. What's the square root of -4? What's the square root of 4? 2. What happens if there's a negative under the square root? What comes out? An I. Perfect, Paula. Good. Hey, I found my other 2 zeros. They're complex. They're numbers that have the i's in them. 2i and -2i. That's still 3 zeros. It may not have shown up on the graph as having 3 zeros because it only crossed the x-axis once. That's the thing with complex solutions. They're not going to show up in the graph. So you've got to use the real ones that you have and then break it down into a quadratic so that you can get your imaginaries or your complex solutions out of that. So keep that in mind that you could have imaginary or complex solutions as well. That just involve, you're going to have to involve quadratic formula or solving by square roots like we did here to get there. But you need to do synthetic division. Still the same process. Do synthetic division until you get it to a quadratic. Then you can take it and say, oh, well, then now I'll just do quadratic formula. And if it's a negative under the square root, then it turns into a nice little complex number for a solution out of that. That's what builds from there. Okay. All right. Let's 1, 2, 3, 4, 5. I lied to you. We're going to do one more of those, and then we'll take a short break and come back and finish off the day. We're going to take a little 5-minute break here. So what letter are we on? In O. Example O. We're going to find all the zeros for this polynomial. F of x is equal to x to the fourth minus 7x cubed plus 18x squared minus 22x plus 12. All right, so got a fourth degree polynomial. So that means how many zeros should I have? It's x to the fourth power. That means I've got to have 4 zeros. Okay. So from there, what's the first thing we do? I hope that you make your P over Q list. I know that seems like a formality and you're not really using it that much, but promise me that you're going to do that, because you're going to have a question on your final that is exactly that, and it's nothing else. And if you can't make that P over Q list, you're missing one of the easiest problems on the final. And trust me, you need every problem correct on the final that you can get, because it's everything we've done. So it seems overwhelming when you look at it like that. But the P over Q list is one of the easiest questions on there, and it will be on there. I promise. Always is. All right, so we got factors of 12 over the factors of 1. So that's 1, 2, 3, 4, 6, and 12. Yeah, 12 different possible answers out of that. And then I'm going to do synthetic division. How many times do we need to do synthetic division on this problem? Twice, yeah, because it's fourth power. It's going to take 2 times to get it down to an x squared. Okay, so what's the next step? I hope it's graph it. So we got x to the fourth minus 7x to the third plus 18x squared plus 22x plus 12. I'm graphing that, and I see it only crossing the x-axis in 2 places, but that's okay. That doesn't end the game. I mean, it just means I've only got 2 real zeros. I must have a couple of complex zeros. That's what that tells me. I also know that those 2 real zeros are don't have even multiplicities, because it doesn't bounce off the x-axis. We know that positive 2 and positive 3 are the real zeros here, and we know that that's going to they're going to have an odd multiplicity, either once or 3 times. I would say that's most likely they're only once each, because the graph has a little bit of a change in direction here in that little elbow right there. Okay, so but that's just experience seeing a bunch of these over the course of my lifetime. You see those things happen, you kind of know what's happening. All right, so I'm going to use 2 and 3. It doesn't matter which order you use those in. It's going to work either way. I'm going to start with 2. And run that through with synthetic. So I have my zeros list over here. I get x equals 2. I know x equals 3 is the other one, but I'm going to use it in synthetic division. No idea why I made it so large. Synthetic division with that part. Okay, I know x equals 3 is one of the zeros. I already checked it with my calculator. I know that. But I need to break down the polynomial using synthetic so that I can find the other two that I didn't see. There's the verification that 3 is a 0 of the polynomial. All right. Now, from there, I have a quadratic. I got x squared minus 2x plus 2 is equal to 0. And I've got to try to solve that. Well, if I tried to factor it, there's nothing that multiplies to be 2 and adds to be negative 2. So that's out. Can't do that. So I've got to do quadratic formula here. Negative b plus or minus b squared minus 4a times c divided by 2a. And I'm going to do the discriminant part over here. It'll be 4 minus 8. It's negative 4. That's what we kind of thought was happening. We thought we probably had a couple of complex solutions here. So that's 2 plus or minus the square root of negative 4 over 2. What is the square root of negative 4? 2i. What do we know about 2, 2, and 2? They're all divisible by 2. So that ends up being 1 plus or minus 1i. And so I have 1 plus I and 1 minus I as zeros of this polynomial. And then 2 and 3 are the real zeros of that polynomial. So it's not not anything crazy there. So it takes all of these parts here to try to build, get the zeros of the polynomial. All right. So let's take a quick short break, and we'll come back. And the next thing we're going to do is, given the zeros, build the polynomial. So work backwards from this. So I want to take a break here and then come back in just a second. So let's take about a 10-minute break, go to the bathroom, splash some water on your face, that sort of thing. And then we'll come back and finish up.